I record all of the lessons and post them on the class website via Student View. Student View, class website on the left-hand side. And change the drop down to Good Now, and you'll see all the links. And yes, I have my own YouTube page, and my own YouTube web. Yeah, you Bye Girls. Yeah, so that's where you'll find it. But there's a link for the video.
Do we turn in our planners?
Do you turn it in? No. Just leave it in your notes for now. Yeah, you're gonna just write your notes right down there. Yeah. Good. Yeah, so this stuff goes in your planner. If you don't have a planner, then it just goes in your notes. All right, because you want to know what problems you need to do for your homework. So you got to write that down. Okay. And so today is the second, and we are just doing a quick review of parallel lines. A really, really quick review. So parallel lines cut by a transversal. So parallel lines have a whole lot of really, really interesting properties. And you know, I love geometry. I taught geometry and honors geometry for a number of years. And I love the actual application of geometry. And they use it all the time in construction. It's so useful and, you know, really cool. So let's say here's one line, and of course a line has arrows that go on forever in both directions. And then here's another line, and I'm going to say that line, I'm going to do some labeling. Line L and line M are parallel. All right, so line L is parallel to line M. Do you know this little symbol for parallel? Yeah, okay. And the notation on lines are these little arrows that denote that those lines are parallel. And then those parallel lines happen to be cut by a transversal, and transversal just transverses, it goes across. And so here is another line, and it's supposed to be a straight line, not that curve that you're looking at. There you go, okay. So there's my two lines cut by a transversal. And when I cut those two lines, I create a whole bunch of angles. Like, I'm going to call this angle 1. I'm just going to label it 1, and a 2, 3, 4, 5, 6, 7, 8. And so I just want to really fast review what those angle relationships are. Okay? So tell me about angle 1 and angle 4. What kinds of angles are angle 1 and angle 4? You know the name? What do you got? Vertical angles. Very good. They're called vertical angles. What are other vertical angle pairs? 2 and 3, 5 and 8, 7 and 6. Good, good, good. And tell me what's nice about vertical angles. Congruent. Vertical angles are congruent. This is I like to write little statements like this. When I taught geometry, some geometry teachers are like, Theorem 31. What the hell is Theorem 31? It's useless. So my students always learned to write a short, like, text version of the theorem. Vertical angles are congruent, all right? And it has way more meaning than Theorem 31, because you're not going to remember that Theorem 31 was vertical angles are congruent. Plus, every textbook is different. So, all right. So vertical angles don't necessarily apply to parallel lines all the time. So now I want to talk about some actual angles involving parallel lines. So let's see. I'm going to talk about here. Angle 1 and angle 5. What kind of angles would you call angle 1 and angle 5? Corresponding. Good. Are corresponding. Corresponding angles. So what other angles are also corresponding? 2 and 6? What else? 3 and 7 are corresponding. 4 and 8 are corresponding. And what do you know about corresponding angles? They're what? Congruent, yeah, good, good. Corresponding angles are also congruent. So angle 1 and angle 5 are congruent. They are equal to one another. They are the same measure, okay? 4 and 8 happen to be the same measure, all right? All those corresponding angles are congruent. All right, let's see. What about, what would you call angle 4 and angle 6? What you're saying is true? I know what you mean. What's their name? You're close. Okay, so are they interior or exterior? Interior. Why are they interior? Inside the parallel line, so interior. So I'm hearing alternate interior. So alternate, are they alternating? No. So yeah, so there's a couple names. So some books call them same side interior. I learned it as, so angle 4 and angle 6 are consecutive interior angles. And what do you know about consecutive interior angles? They're supplementary. Very good. So the measure of angle 4 plus the measure of angle 6 should equal what? 180 degrees. Very good, because supplementary means 180 degrees. Good, good, good. And let's see. Oh, so there's all sorts of names, right? I'm not going through all of them, but I just want to remind some of us. So what about here? I'm going to make this one this way. Angle 2 and angle 7. Very good. They are alternate exterior angles. What do you know about alternate exterior angles? I heard supplementary and I heard congruent. What are we thinking? Congruent. Yeah, yeah. So they are congruent. So angle 2 is congruent to angle 7. They have the same measure. They're equal to each other. I had to work through that myself. I was like, angle 7 and 6 are vertical, so they're congruent. And angle 6 and angle 2 are both corresponding, so they're congruent. And if A is to B, as B is to C, then A must also be C. Ooh. All right. Did you follow that? Did you follow that? Woo, baby. Okay. That's a little transitive property thrown in there for you. Okay. Whew, that's 6 bet. It is hot in here. Is it hot in here to you? Like my palms are sweating. It's so hot. Okay. All right. Okay. So really good stuff here. I think that's a good review. So let's do one problem. I'll give you a second to copy this down. Example 1. Again, example 1, find the value of the variables. This is stuff I expect to see in your notes. Of course, that stuff too I just wrote down that should be in your notes. That's helpful information. You guys don't really have a textbook. Well, you do, but we don't have enough of them, of course, because this is TUSD. You know, your notes effectively become your textbook, all right? So it's really important you do your best to have really awesome notes. Find the value of the variables. So they really want us to find the value of X and Y. They have questions like this on the ACT. And but they're not going to ask just find value of X or find the value of Y. It's always going to be like find the measure of angle ABC. So you always have to, plug that value back in and figure out what it is. So they're always going to ask you that one extra step. Here on the lower left, this angle measure, and they're talking about this angle right here, 3x minus 5 degrees. I also want to point out that these are the parallel lines. I didn't put that drawing on. I do all these by hand, so in PowerPoint. Down here, we have 6y plus 35 degrees. Below that, 2y minus 7 degrees. And then the far right one, 2x plus 7 degrees. So we do know that we have parallel lines. So what are you thinking that you can do? Because you're all sitting there puzzling through. I love it. That's awesome. You're all thinking about how you're going to figure this out. Let me see if I can actually figure out some things here. Okay. You are. You go by Alexander or AJ? Okay. AJ, what were you going to say?
3x minus 5 and 2x plus 7 are alternate exterior.
Okay. So 3x minus 5 and 2x plus 7 are alternate exterior angles. And what do we know about alternate exterior angles? They're congruent. Perfect. And what's really nice about what AJ said is that they both have what variable in them? X. Yeah, so really important. Obviously, we can't solve one equation when we have two variables without some extra work. So 3x minus 5 should be equal to 2x plus 7. And then we can solve a real simple linear equation. So how do I do that? Oh, thank you. 2x plus 7. Thank you very much. Okay, how do I solve this equation now? Add 5. I heard add 5 first. I could do that. Okay, again, you don't have to write this step, but I'm usually going to show a lot of steps when I do notes. Okay, and then what? Put the variables on one side so we can subtract the 2x. Okay, so then you get 1x is equal to 12. And there's one value of the variable. Now, that's great, and I'm glad you looked for those like things. Now, there are all sorts of ways to solve the next part. So what do you want to do now? You are, hold on. You are Adrian.
So you can plug x ducks into the equation with 2x plus 7.
Oh.
You do 6y plus 35 plus whatever 2x plus 7 is equals 180.
Oh, okay, good. So you're seeing here, boy, I hope that works. I didn't do that. I had to make up this problem on my own, right? So I don't know if I checked every combination. I hope that works. Yeah, lots of different ways to do this. He said we can plug this 12 back in for x and figure out what that is. I hope that works. So we're going to give it a try. So I'm going to plug that in. 2 times 12 plus 7 is what? 24 plus 7, 31. So this should be 31 degrees for this little angle here. And so then Adrian said 6y plus 35 and this 31 degree angle over here, they are what kind of angles? What is that called? They're supplementary. It's also a straight angle. They are supplementary. So 6y plus 35 plus this 31 degree angle should equal 180 degrees, right? Okay. I sure hope so. 6y plus 66 equals 180. And now what should I do? Subtract 66. I hope this doesn't explode in my face here. 180 minus 66 is 114. Oh, son of a gun. Does it work? Yeah. It does? 19? Holy mackerel, I did it right. Okay, cool. It's always a question. All right. Okay, do you have any questions for me? It's easy, right? Good? Okay. All right, that's all I'm going to do. I'm going to get that. I'm going to show one up here just so it's in the video. So here is that homework. It's really small. I don't know. That's the best I can do right now. But you're